Alright, in this lesson we're going to factor ax squared plus bx plus c, and a does not equal 1. This is what's different about this one. It's a trinomial, but there's a number in front. I'm going to show 3 different methods. Each of them have their merits, and you might like one more than another, so get ready. Method 1, I call it regrouping. It's 4 steps. We find 2 numbers whose sum is b, whose product is ac. That's a little different than before. ac now. What we do with it is also different. We rewrite the middle term, the bx term, using these numbers. Third, we'll factor a GCF from the first 2 terms, and we'll factor a GCF from the last 2 terms. Finally, what will remain is a binomial factor GCF. I'll show you an example of this. We're going to factor 2x squared minus 7x plus 5. The sum is negative 7. The product is positive 10. Now, because the product is positive but the sum is negative, we need to think about the signs for a minute here. I could either have 2 positives or I could have 2 negatives. Looking at the sum, we'll notice that the sum is negative. So this is what we want, 2 negatives. We either have the numbers 1 negative and 10 negative, or 2 negative and 5 negative. This is the one we want. Here's what we do. We keep the 2x squared, and now we're going to rewrite that second term using those 2 numbers. Notice how negative 2x minus 5x equals negative 7x. We're not done. This is not factored. It's a strategic rewriting. We're regrouping. Now we're going to look at the first 2 terms. They have 2x in common. Write the remainder. You might want to pause and see how you do. In this case, it's x minus 1. Now looking at the next 2 terms. Well, I can see they have a 5. I can either choose to take out a positive 5 or a negative 5. I'm going to choose to take out a negative 5, and you'll see why in just a moment. The remainder now is x. Because that was a positive 5, and I took negative 5 from it by division, the remainder is negative 1. Check your work by multiplying. Notice what happened now. This binomial and this binomial are the same as each other. Step 4 says we will have a binomial GCF, and we do. The remainder is the 2x from out in front of the first term, and a negative 5 from the second term. It's fully factored now, and you can FOIL it to check your work. Alright, that's the first example. You may want to study that one a bit. It always works, but it does take a bit of effort. The second example, this one's a little bit trickier to get hold of, but once you do, you might really like it. It's kind of a shortcut method. Now to start, let's look back at the last example. We had the trinomial 2x squared minus 7x and 5, and we found it had these binomial factors, x minus 1 and 2x minus 5. Now just recall, if I were to check this and FOIL this, it would be x times 2x, that's my f. It would be x times negative 5, that's my outer. It would be negative 1 times 2x, that's my inner. And it would be negative 1 times negative 5. That's my last, FOIL. Now, the number in front of the x here is a 1. Maybe I'll put that in there just to emphasize the idea. What I'm going to do over on the right here is I'm making a chart. And in this chart, the numbers along the left side that I'm going to choose are going to make the f of FOIL. So I'm going to put the 1 and the 2 here, because I have 1x and 2x. Or, if we hadn't yet factored this, and we were starting from the trinomial, we'd look at that 2 and ask ourselves, what numbers multiplied make 2? Well, 1 and 2 do. Now over on the right column, this part is going to be the multiplication that makes the L. I'm going to come back to the OI in a minute. L is how do I make the last term, a positive 5? Well, I make it with 1 and 5, and the only question is the signage. This is positive, meaning I could have 2 positives multiplied or 2 negatives multiplied. When I look at the sum, it's negative. So I know these two numbers are negative. We already discussed that in the last example. So I am going to go ahead and put two negative signs here representing the signs I know that exist there. All that remains now is to figure out, should I put a 5 and a 1 or a 1 and a 5? Let's try a 5 and a 1 like this. Now here's where my OI come in. This is the O, this cross multiplying, and this here is the I. So checking 1 times 2 for my F, I get my 2x squared. That's good. I already know the negative 5 times negative 1 makes my positive 5, so my L works. Now let's check the OI. 1 times negative 1, that's negative 1. 2 times negative 5 is negative 10. I can't combine those to make the negative 7, so I've chosen incorrectly. Let's scratch those out and try again. I'm going to put negative 1 here, put negative 5 over there. Try again. Going diagonally this way, I get negative 5. Going diagonally this way, I get negative 2. Negative 5 and negative 2 makes negative 7. So I've found my correct answer. All that I need to do is interpret what this chart is saying. What the chart is saying is that I have x minus 1. I'm reading along the top row. X minus 1. The next row tells me 2x, that's what that means, and minus 5. And you notice that I have the same factor pattern. Now, I got one more method to show you. This one's a little bit strange, but it's kind of neat. The AC method. There's your set of instructions. You could pause it now if you want to read that over, but I'm going to just go ahead and start doing this process to show you how this works. I'm going to use the same example again. So I start with 2x squared minus 7x plus 5. What I'm going to do is I'm going to rewrite this as x squared minus 7x plus 10. I'm going to recognize that my numbers are negative 2 and negative 5, as we've established before. I'm going to put those in here right away. X minus 2, x minus 5. Now, what I do next, step 4, is I divide each constant term by the A. The A was a 2. There's a constant term. There's a constant term. I simplify, getting x minus 1, and because this is a fraction, I move the 2 in front of the x, and I leave the 5 there. Done. Those are the three different factor patterns that you need to choose between and get good at least one of them. I'm going to leave you with one other thing, and that's a special factoring pattern that you need to know about. The perfect square trinomial. We've already seen the binomial square. Remember, now we're working backwards with factoring, so we want to recognize how that trinomial becomes that binomial square. There are a set of steps that you can follow. First, always remove GCFs. Always, always, always do this. Second, if you have a perfect square trinomial, the last term will have to be positive. Third, the first and last terms must both be perfect squares. And lastly, this one's a little tricky, the middle term in that trinomial is the root of the first term times the root of the second term times 2. I've got two examples to demonstrate this with you. In this first example, no GCF. Is the last term positive? Yes, it's positive. Are the first and last terms perfect squares? This is a perfect square, this is a perfect square. We're doing well. So the next question is, does 6x equal the root of the first term times the root of the last term times 2? Well, this is x, this is 3, this is 2, 6x. Yes, it does. This is a perfect square trinomial. All right, let's look at this last one. 12, 60, and 75. I have a common factor this time that I need to remove. Step 1, always try to remove any common factors. So what I'm going to do here is I'm going to remove 3. I write the remainder. Now I'm going to look at this trinomial. Is this positive? Yes, it is. Is the first term a perfect square? Yes, it is. Is the last term a perfect square? Yes, it is. And does 20x equal the root of the first term times the root of the last term times 2. Well, this is 2x, this is 5, and 2. 2 times 5 times 2, 20x. Yes, it does. 2 examples of perfect square trinomials.